Hello, my amazing students. We're on 3.3, and 3.3 is all about analyzing graphs of quadratic functions. And so we'll be talking about how to find the vertex, how to put the equation in vertex form, what an axis of symmetry is, things like that. So our first problem is number 10. And we are supposed to find the vertex, the axis of symmetry, whether we're talking about a minimum or a maximum at the vertex, and then we're supposed to draw the graph. Okay, so the first thing I did was I took my equation right here, and I found my negative b over twice a here, which is the x value of your vertex. Remember, this negative b over twice a will always give you the x value of the vertex, which is also your axis of symmetry. So I figured that out, and I found out that I have a vertex where x is equal to 3. So then what I do with the 3 is I plug the 3, oops, that was a positive 3, not a negative 3, plug the 3 into the equation. So I plugged the 3 in, and I did my work down here, and I wind up with getting a negative 2. So the vertex is 3, negative 2. Now, what I do with that vertex is I'm going to use it to graph with, of course, but the x value of the vertex is my axis of symmetry, which was the second thing I was supposed to find. And since my parabola is going up and down like this, and that's my x-intercept, x part of my vertex, I'm going to call my axis of symmetry x equals 3. And then I notice that this x squared over 3, which is my quadratic term, the quadratic term is your x squared term, and it is what makes your equation quadratic, a parabola instead of a line. And that term is positive. And since it is positive, then this point right here, my vertex, is a minimum. And then I needed to graph the whole thing. So what I did is I put the graph on the right here, but on the left I calculated some points. So basically I knew where my vertex is. My vertex is at 3, negative 2. And then I knew that I had symmetry on each side of that x is equal to 3 line. And so I chose points an equidistance from 3 on the x-axis. So I chose 3, and then I put a 4 and a 2, which are on either side of 3, and I calculated by plugging into the equation, and I ended up getting negative 5/3 for both of those. So at 4, I get a negative 5/3, and at 2, I get a negative 5/3, and I graphed those. And then I went one more step to the right and the left, and that was at 5 and 1 from the point x is 3. And I calculated them out, and I ended up getting negative 2/3 for each one of those. So remember, a 1/3 graph, which is what this is here, it's an x squared over 3. So I have a compressed graph, and it's a flatter graph. It's not as sharp as the normal x squared graph. And so I expected it to be wider, and it is. And so here, just two steps away, I'm still below the x-axis. Then I had one more point that was kind of a gimme. All right, I know that if I take this equation here and I plug in a 0 for x, I get out a 1 for y. And remember, when I plug in a 0 for x, I'm finding my y-intercept. So my y-intercept was 1. And the y-intercept of 1 is right here. So I'm showing it crossing the y-axis at 1. But that y-intercept was 3 steps away from the axis of symmetry. And so I also have another free point 3 steps to the right, or at 6, I also have another point that is going to be symmetric to this point over here. So 6, 1 was also a point on my graph, and I didn't even have to calculate that. I just needed to look at the 0, 1 and know that if I had a 0, 1 to the left, then I had a 6, 1 to the right. And that's a pretty good graph, and we'll go on to the next problem. All right, so now we're doing number 16, which is similar to the first one that we did. And we have our equation up here. I calculated my x value of my vertex, which is negative b over twice a. And when I plugged that in, I got a negative 1/2. Then I took the negative 1/2 and I plugged it back into my original equation to get the y value of the vertex. So my vertex is at negative 1/2 and 7/4, which I wrote on this screen here. So there's my vertex. It is facing downwards. Notice that my original up here at the top had negative 3x squared. So since the quadratic term was negative, then I know that my graph is facing downward, a downward facing parabola. Therefore, the vertex is a maximum because it's the hill, the top of the hill. The axis of symmetry is the x value of the vertex. X is equal to negative 1/2. And our graph looks approximately like that. Okay, so negative 1/2 and 7/4 is a little bit less than 2. I did have one extra point because when I look at this, isn't my y-intercept equal to a 1? If I plug in up here at the top, x is 0, I get y is 1. So my y-intercept was a 1, and therefore I knew I had also a mirror point on this side of the axis of symmetry. All right, then we did number 24. Number 24, 17 through 24 are kind of fun because they give you some graphs at the top of the page, and we're to match the equation to the graph. So on number 24, I took the equation and I analyzed it a little bit. The 2 on the front means that it's going to be a vertical stretch. Okay, so it's going to be sharper and skinnier. The x minus 1 means that I have a shift 1 to the right, and that's going to affect my x coordinate. And then I've got a shift 4 steps down. So my vertex, remember this is the vertex form of the parabola, and my vertex is 1, negative 4. So all I did was look on the graphs, and when you look at the picture of all of those graphs there, then you can see that D looks like the one that they are describing with a vertex. So here's D right there with a vertex of 1, negative 4. All right, and we'll come back with some more. All right, so now we're doing number 31, and 31 is up here at the top, and by the time I figure out my negative b over twice a, I get a 3, and then I plug in the 3, and I get a negative 4. So my vertex is 3, negative 4. Now on this one, we were supposed to talk about whether the vertex was a maximum or a minimum, and since this first term, the quadratic term, is positive, then my parabola is going to be facing upward, and its vertex is going to be 3, negative 4. Okay, so because of that, we're also talking about whether the parabola, so since it's facing up, the range, now the domain of all of these upward or downward facing parabolas is all real numbers. The domain is all real numbers, but your range is limited. So your parabola doesn't start until it gets to 3, negative 4. So the y value, the range, has to do with the y value of your parabola. And so since it's starting at negative 4 and going up to positive infinity, we would say the range is equal to negative 4 to positive infinity. and it looks like the -4 is included, but then the infinity is not. So we would put a bracket on the left and a paren on the right. Now, if I were going to talk about the area or the ranges, the intervals where the function is increasing and decreasing, I could say that it is increasing from 3 to positive infinity. Okay, and usually when I'm doing these, I do not include the 3 because at 3 it's neither increasing or decreasing. So I usually would say increasing is open paren from increasing is from 3 to positive infinity, because that's this side where it's increasing, and then decreasing would be from negative infinity. So decreasing would be from negative infinity to 3. Okay, so they are analyzing each one of these things in this parabola. Okay, it says find the vertex, determine whether that is a maximum or a minimum, and find that value. So the minimum value of the function is at the vertex. It's -4. Okay, so when they're talking about the value of the function, that's your y. So the minimum value is -4. And then it says find the range, which we did, and find the intervals where it is increasing and decreasing. So let's do one more of those. And we're doing number 40 now. And here's the parabola at the top of the page. I found the -b over twice a to be 3/2. And then I plugged the 3/2 into the equation, and I found out that the y value that went with the 3/2 was 1/2. So the y value of the vertex was 1/2, and the x value of the vertex was 3/2. So what I have is a parabola, and since the first term is positive 2x squared, we're going to have an upward facing parabola. So the vertex is 3/2 and 1/2. So we have an upward facing parabola with the vertex at 3/2 and 1/2. This is a very rough graph, but it's sufficient to do what we need to do. We need to talk about whether our value for our vertex is a minimum or a maximum. And since we have an upward facing, this is the bottom of the valley, so this is a minimum. Okay. We also needed to know what is the range of the whole thing, and the range of the function is what's happening with the y value. And the y value is starting at 1/2 and going to positive infinity. So we would say bracket 1/2 because the 1/2 looks to be included, and to infinity. That would be the range of my whole function. And then if I was going to analyze where is it increasing and decreasing, okay, then it is increasing starting at x is 3/2 and going up, continuing on till positive infinity. So it's increasing is from 3/2 to positive infinity. And because at the vertex it's not increasing or decreasing, I leave the vertex out. And then decreasing on this side of the parabola down here. So from negative infinity until we get to x is 3/2, we have the interval where it is decreasing. Now remember, some of you did this on the first test or the second test that had increasing and decreasing intervals, and you tried to stick the y's into those intervals. Your intervals of where you are increasing and decreasing has only to do with the x value. So don't throw the y values in there. You're going to lose points if you do that. Okay, so that's the way that you should do it correctly. Okay, now your range should have to do with your y values, and your domain has to do with your x values. All right, so we come back with another problem. All right, now this is number 43, and 43 is giving us the information about a rocket that is being launched at an initial velocity of 120 feet per second from a height of 80 feet. And then they give us the equation. We don't have to come up with that on our own. Then they want the t, or the time, when the rocket reaches its maximum height. And then they want the value of that maximum height. So what they're really asking for is, what is the x value of the vertex and what is the y value of the vertex, is what they're saying. So to find the x value of the vertex, we know we're going to use negative b over twice a. Okay, so when we plug in the negative b, that's going to be negative 120 over twice the negative 16 is a negative 32. And the negative divided by a negative is going to give me a positive. Okay, and I know that 120 divides by 4 with a 30. And I know that 32 divides by a 4 with an 8. And so that's going to be a 15/4. Okay, so 15/4 is the x value of the vertex. And if I were going to divide that out to make it a little bit more reasonable, in other words, I wouldn't go around saying I have 15/4 of a second. I would, 15 divided by 4 is 3, and then I have 3/4 left over. So 3.75 seconds is how long the rocket is in air before it hits its highest point. Okay, so then I'm going to take that 3.75, and just for ease, I'm going to put it back in its fractional form. So I'm going to go back to 15/4 because I have to actually put this into the equation. So I have negative 16 times 15/4 squared, okay, and plus 120 times 15/4, okay, plus 80. All right, and so that's the equation. We do all of the math, and the height of the rocket should go up to 305 feet when I do all of that calculation. Okay, so when I calculate all that, that is the height of the rocket. So I'll let you do those calculations, but you're just plugging it into the equation, and you're using your order of operations and squaring that, and it comes out right. Well, this one is very interesting, and this is number 45 in your book, and it shows a picture of a sheet of plastic that is 10 inches by 18 inches long, and they're trying to fold this plastic on lines that are a certain distance from, and you can see a better picture, so it makes a kind of a sharp U shape, a box U shape, and they're saying, okay, this is like a vertical file container that's going to keep the maximum vertical files volume. Okay, so basically I added this in here. If we have 18 as the length of the sheet of plastic, and then we're folding up a side X on each side, then we're going to have 18 minus twice X is going to end up being the bottom of this file. And then the file is going to be 10 inches deep, and it's going to have an 18 minus 2X width. And then the height is going to be X. So what I did is I just made an equation for the volume that this file could hold. And 10 for this depth of the file here, and then 18 minus 2x, which would have the bottom part of the file, because to find volume, you're going to find the area of the base times the height. So the area of this base in here, when we fold up those sides, is going to be 18 minus 2x times 10, and then the height is that x that we're folding up. So when I multiply all three together, I get a good formula for the volume of this vertical file. So then when I multiplied all this out, I got 180x minus 20x squared, which is a little backwards because for me to have it in its standard form, I need to have my minus 20x squared in the front, and then this would be my b term, or my linear term. So when I went ahead and plugged in my negative b over 2a right here, then I ended up with my negative b being the negative 180 divided by twice the a here in front of my quadratic term. So that became a negative 40. And when I did the math, I came out with 4.5. So 4.5 inches is how much should be folded up. So this X, this fold, should be 4.5 inches. And the problem didn't ask you, but I was curious, you know. I had to go in and figure out what was the maximum volume. And the maximum volume of that file was 405 cubic inches. Okay, but this is what they ask you. They ask you how much should you fold up to obtain the maximum value. Can you see that all we're looking for here is the vertex? Because since this is a negative 20x squared, this is a downward facing parabola, and its highest point is going to be the vertex. So all we're doing is finding the x value of the vertex. And if we want to find the volume of the resulting file, we're just finding the y value of that same vertex. All right, so I did number 47 for you also, which was an interesting one. And it just gave you the sum of the base and the height of a triangle is 20 centimeters. Okay, so they've given us some information. The area of a triangle, we should know, is 1/2 base times height. So here's our area formula. And then I took this piece of information, base plus height is 20, and I solved it for h. H is equal to 20, take away the base. And so now when I plug h into here, then I get an expression for the area that is just in B, or base. So area is 1/2 base times height, but 1/2 base times height, I substituted in this formula for the height. So now I only have one variable, and when I distribute that out, I get 10b minus 1/2 b squared, which is not in standard form, but it is the area of said triangle. So now I rewrote the area in its correct form, which is negative 1/2 b squared plus 10b. And the vertex is going to be where that area maximizes, isn't it? So the vertex is negative b over twice a, which winds up being 10, and that's the x value of the vertex, which is the x value of the, so the height, so the base is 10. So then I took the height and I went and I plugged in 20, take away the base is the height. So both the base and the height need to be 10 to get your maximum area. The maximum area was the y value of the vertex. So when I plugged in the 10 here, I got 50, which was the y value of the vertex. That was the maximum height, the maximum area of this triangle. So the dimensions were base 10 and height 10 is what would give you the maximum area of 50. So I think we have done enough on 3.3 for you to get a good idea of how to analyze quadratic functions and also to maximize and minimize. So because quadratic functions have their maximum or minimum at the vertex, you are able to do that algebraically. You could also stick the equation into your graphing calculator and you could analyze it that way, but to me that would be the long way to do it. I would rather do it with a just finding the vertex of the equation. And this is Mrs. A, and may God bless your day.